What if life on Earth began not with gentle beginnings, but with fire and destruction? What if everything we know, the oceans, the continents, even the chance for life itself, was sparked by the violent death of a world that no longer exists? It is not a story of peace. It is a story of survival, born in chaos. Billions of years ago, when our solar system was still young, Earth was not the stable, welcoming world we know today. It was unfinished, incomplete, and waiting for something extraordinary to change its fate. That something came in the form of a planet scientists call Theia, a world that once circled our sun, now gone forever. Its existence is known only by what it left behind: fragments scattered deep inside our planet, whispers etched in the moon, and the possibility that its destruction gave rise to life itself. But before we reach that fateful encounter, we must step back to a time when Earth was only one of many fiery bodies circling the sun, to an age of raw beginnings when creation and destruction walked hand in hand. The young solar system was nothing like the orderly place we see today. There were no calm orbits, no predictable paths traced through the dark. Instead, the sun blazed as a furious young star, its light scattered by clouds of dust and gas, its gravity pulling countless fragments into unstable motion. Imagine vast belts of debris circling in chaotic swarms, planets still forming, their surfaces molten, their atmospheres toxic. The space between worlds was thick with collisions. Mountains of rock slammed together, shattered, melted, and then reformed into new shapes. Every planet we know today was once born from these violent mergers. Amid these churning orbits and molten worlds, Earth, too, was part of this turmoil. In these early days, it was not the home we know. It was a fiery sphere, its crust thin and unstable, its skies filled with poisonous clouds. Volcanoes raged endlessly across its surface, and rivers of magma stretched from horizon to horizon. But Earth was not alone. Surrounding it were other worlds, some large, some small, each carving its uncertain path around the sun. Among them was Theia, a planet nearly the size of Mars. At that time, it was just another body in the crowd, circling in its orbit, seemingly ordinary. Yet destiny was already pulling it closer and closer toward Earth. This was an age when nothing was secure. Orbits shifted constantly, tugged by the immense pull of giants like Jupiter and Saturn. Smaller worlds were flung away into the emptiness, lost forever. Others spiraled inward and were consumed by the blazing sun. The early solar system was less a peaceful family of planets and more a battlefield where survival depended on chance. Earth survived, but it was far from complete. Despite its growing size, it lacked balance. Its surface was unstable, its spin irregular, its climate harsh. Life, as we know it, could never have taken root. For Earth to transform into a habitable planet, something profound had to occur. And it is here that the story narrows, focusing on the delicate pull between Earth and Theia, a slow, inevitable dance of gravity that would lead to the most consequential collision in the history of our world. But before that encounter, Earth remained fragile. It circled the sun as a fiery globe, waiting for change. To understand the stage on which this drama would unfold, we must see the sun not as the familiar star of today, but as a young furnace. It blazed with a strength greater than we now feel, its surface more violent, its storms more furious. Streams of charged particles lashed outward, striking the young planets without mercy. For Earth, this meant its thin, unstable atmosphere could not hold. Each solar storm stripped gases away, leaving a world exposed. What little air existed was a toxic haze, heavy with carbon dioxide, methane, and water vapor. To breathe here was impossible. And yet, hidden in this poison were the very building blocks of the future. They carried the seeds of oceans and skies, though at the time, they lingered only as suffocating clouds above seas of fire. Elsewhere, chaos ruled. Mars was smaller, cooling quickly, but still volcanic. Venus was a twin of Earth, shrouded in dense and deadly fog. Beyond them, the gas giants drew in stray fragments, reshaping the balance of the system, their immense gravity changing the paths of smaller worlds with every tug. This was the stage of fire and chaos, where Earth was a player, but not yet the world it would become. When we look back at Earth's earliest days, it is tempting to imagine a planet much like today, only harsher. But in truth, Earth was almost unrecognizable. Its surface was a restless ocean of molten rock. Any attempt at a crust was shattered again and again by constant bombardment from space. Asteroids the size of mountains rained down, their collisions releasing enough energy to vaporize rock and boil entire seas of lava. Even Earth's rotation was unstable. It spun at a different speed, tilted at uncertain angles, making days and seasons unpredictable. It was a planet caught between formation and destruction, always changing, never at rest. And yet, even here, something remarkable was happening. With every impact, with every surge of volcanic fire, Earth was gathering material. Heavy metals sank deep into its core. Lighter elements spread to form its crust. Bit by bit, the planet was shaping itself, even as it was constantly torn apart. But something was still missing. Balance, stability, a way for Earth to calm and sustain itself long enough for life to one day arise. That missing piece was already nearby. Theia. We often imagine planets as steady objects, locked in their places, circling the sun like clockwork. But in those early days, nothing was fixed. Orbits crossed, worlds wandered. And so Theia, once traveling peacefully, began to drift closer to Earth. At first, the two planets circled in harmony, their gravity pulling gently but not yet colliding. Yet with each passing million years, the distance closed. Tiny nudges from other worlds, Jupiter, Saturn, even Mars, shifted their courses just enough. One day, their paths would meet. For now, Theia remained a silent neighbor. We know little about it, only that it was real, and that it was large enough to rival Mars. It may have had its own mountains, its own volcanoes, perhaps even a thin atmosphere. But none of that remains today. Theia exists only in fragments, hidden within Earth and within the moon that circles us. Its true story begins with its approach. As Earth circled the sun in its fiery youth, it was incomplete, unstable, unfinished, waiting for something that could transform it. That transformation would not come gently. It would come through violence. The approach of Theia was not just another random encounter among many. It was the spark that would define Earth's destiny. Out of their collision would come a new balance, a new world, and the possibility for life itself. But before we tell that story, we must look more closely at Earth in its raw, unshaped state. To understand what was at stake, we must see just how fragile it truly was. Molten rivers flowed endlessly across its surface. Poisonous skies stretched overhead. Earth was alive with fire but dead to life. It was not ready for oceans, not ready for air, not ready for the fragile spark of biology. It was a world incomplete, a world waiting. And in the shadows of the solar system, Theia circled ever closer. Earth, in its earliest days, was a planet of fire. To imagine it then is to step into a world unrecognizable from the calm blue sphere we know now. Instead of oceans and continents, there were rivers of molten rock flowing in every direction. Instead of skies filled with soft clouds, there was a heavy atmosphere, thick with choking gases, pressing down on the land like a suffocating blanket. The heat was unbearable, the air toxic, the surface in constant upheaval. And yet, this was our Earth, young, restless, and unfinished. The planet had only recently taken shape, formed from endless collisions of smaller fragments that had fused together under gravity's relentless pull. But these collisions did not end when Earth became large enough to call a planet. They continued, each one a hammer strike against its surface, each one unleashing unimaginable energy. Entire regions melted anew with every impact, sending plumes of molten rock high into the poisonous sky. What little crust had formed was broken again and again, swallowed by lava oceans that stretched from horizon to horizon. It was not just the ground that was hostile. The air itself was a storm of poison. Carbon dioxide, methane, ammonia, sulfur, and water vapor swirled together, forming clouds so dense they barely allowed sunlight through. The sun's light, already fierce in its youth, was filtered into a dim, orange haze. Lightning forked endlessly across the skies, fueled by the churning gases and heat below. Thunder rolled without pause. To stand there, if it had been possible, would be to stand in a nightmare, a world that shook with every heartbeat, burned with every step, and gasped with every breath. The bombardment from space made this chaos even worse. Asteroids the size of cities, sometimes the size of mountains, struck the planet with unrelenting force. Each one was a catastrophe. The heat of their impact vaporized rock, creating temporary seas of fire. Shock waves raced through the ground, splitting it open, sending molten rivers surging across the land. And yet, these impacts were not only destructive, they were also creative. With each collision, Earth gathered more mass, more raw ingredients that would one day become the foundation of life. Still, in these days, it was a planet no living thing could survive. There was no water in liquid form, only steam that condensed briefly before boiling away again. There was no stable crust, only broken fragments floating on the oceans of magma below. Even the length of a day was uncertain. Earth spun faster then, its hours shorter, its nights brief and suffocating. Seasons, if they could be called that, were wild and irregular. The planet tilted and shifted unpredictably, sending heat and storms across its surface in violent cycles. It was a world alive with energy, but empty of peace. Beneath the chaos, deep inside the planet, something crucial was happening. Heavy metals like iron and nickel sank toward the center, forming a dense core. Around it, lighter materials spread outward, creating the first hints of a mantle and crust. This process of separation was essential, for without it, Earth would never have become stable. But in these days, it was incomplete. Tremors rattled the planet constantly. Magma surged up from deep fissures. The crust, when it did form, was thin and temporary, easily broken by the next eruption or the next impact. The atmosphere mirrored this instability. It was thick enough to trap heat, but not yet balanced enough to protect. Temperatures rose and fell wildly. Sometimes the sky glowed red with volcanic gases. At other times, meteors streaked through the air, their trails burning bright before crashing into the ground. The heavens themselves seemed angry, filled with both destruction and possibility. And yet, for all this violence, Earth was also building itself. Each eruption, each storm, each impact added to its story. The oceans of lava slowly cooled between bombardments, hardening into darker rock. These were the seeds of the continents, though they would not take shape for hundreds of millions of years. Volcanic gases thickened the air, creating the pressure that would one day allow liquid water to pool on the surface. Even as Earth burned, it was laying the foundation for what was to come. Imagine looking at the planet from above. You would see glowing rivers of lava winding across the surface like veins of fire. Volcanoes towered over the landscape, their eruptions sending ash plumes miles into the air. Massive craters dotted the ground, each one still steaming from recent impacts. Between them, pools of molten rock shimmered in the dim orange light of the choking sky. The entire planet looked alive, not with life, but with ceaseless motion, restless and unfinished. This world was not alone in its suffering. Across the young solar system, other planets endured the same trials. Venus boiled beneath its own poisonous skies. Mars cooled quickly, its smaller body unable to hold heat for long. Even the giant planets, far from the sun, battled storms that raged across their immense atmospheres. But Earth was different. It had grown larger than most, heavy enough to hold on to an atmosphere, powerful enough to endure endless bombardment. It had potential, though unrealized, waiting for the right moment. The constant impacts from space also brought with them something else. Locked within the fragments of rock and ice that rained down on Earth were hidden ingredients: water, carbon, nitrogen, and other elements that would someday feed life. For now, they arrived only as fleeting additions to the chaos. The water boiled away into steam, the carbon became part of the choking air, and the nitrogen mingled with the other gases. But they were here, already present, already waiting. The Earth was collecting its toolkit, though the workshop was still aflame. The imbalance of Earth's early state was dramatic. Gravity pulled inward, heat surged outward, and the two forces struggled endlessly for dominance. Each eruption was Earth's attempt to release its inner fire. Each collapse of crust was a reminder of its youth. Even the skies joined the struggle. Storms raged for centuries at a time. Lightning struck constantly, sparking against the volcanic ash that filled the air. It was a world defined by conflict, where nothing lasted, nothing was calm, and nothing could live. And yet, for all its danger, this unfinished Earth was not without beauty. To imagine it is to imagine a world both terrifying and awe-inspiring. The glow of lava lit the horizon in every direction. The sky, thick with ash, painted itself in shades of crimson and gold. Thunder rolled like a drumbeat, echoing across mountains of fire. Even in its chaos, there was grandeur, a grandeur that hinted at the possibility hidden beneath the destruction. Earth, however, could not finish its story alone. It had gathered mass, built a core, formed an atmosphere of sorts. But it was still unstable. Its rotation was irregular. Its surface was fragile. Its skies were deadly. It needed something to tip the balance, something that could bring stability out of chaos. And that something was already drawing near. Theia's orbit was shifting, slowly, steadily, pulled by gravity's hand. Though it had not yet arrived, its influence was beginning to be felt. Each time the two planets circled the sun, their paths inched closer. Each time, Earth's future grew more tightly bound to Theia's. The unfinished world was waiting for the encounter that would complete it. And so Earth spun on, restless and raw. Oceans of magma heaved across its surface. Skies of poison churned above. Asteroids rained down, adding both destruction and possibility. Life was impossible here, but the ingredients of life were gathering, hidden within the chaos. It was a planet not yet ready, a planet in need of change. That change was approaching, silent and inevitable. In the darkness of space, Theia circled, carrying with it the fate of Earth. Their meeting would not be gentle, it would be violent, catastrophic, and final. But from that violence would come something extraordinary. From that destruction would come balance, oceans, a moon, and the chance for life itself. Earth, the unfinished world, was waiting for its transformation. And Theia was drawing closer. Earth, raw and unfinished, turned endlessly beneath its heavy, suffocating skies. The surface heaved and roared, magma bubbling and flowing as though the very ground resisted stillness. Every impact from above shaped it further, yet it remained a world in waiting, a planet not yet ready for what was to come. But Earth was not alone in its journey around the young sun. Far beyond the veil of fiery storms and drifting debris, another body had taken form, a companion, a rival, a twin. This was Theia. Theia was not small, not insignificant. It was a world nearly the size of Mars, forged from the same swirling disk of dust and gas that had given rise to Earth itself. Born of the same chaos, it carried within it the same essential materials, metals and silicates, water-locked in minerals, the building blocks of what might one day have made it a planet with its own destiny. But Theia's story was never to be independent. Its path was tied from the beginning to Earth's, and every orbit around the sun drew the two worlds closer, as though gravity itself had chosen to entwine their fates. In the vast early solar system, hundreds of planet-sized bodies had formed. Many were lost to collisions, shattered and absorbed into larger worlds. A few survived as distant wanderers, banished to the outer reaches. Theia was among those that lingered in the inner system, finding a precarious balance near Earth's orbit. For millions of years, the two circled the sun like uneasy siblings, their orbits weaving a fragile harmony. Earth was larger, more massive, but Theia was swift and resilient. Together they danced a slow and dangerous dance, each pull of gravity bringing them closer to an inevitable embrace. Theia, like Earth, was a restless body. Its surface, too, was marked by impacts, its crust cracked and reformed by endless collisions with asteroids and fragments left over from the birth of the solar system. Volcanoes roared across its terrain, spilling lava into valleys that shifted and collapsed with each tremor. Its skies were filled with the same poisonous haze, a reflection of Earth's own torment. But Theia's smaller size meant it cooled faster, its crust hardening sooner, its surface perhaps briefly more stable than Earth's. For a fleeting time, Theia might have appeared calmer, less volatile, even habitable in its own fragile way. But it was not destined for peace. As the two worlds circled the sun, subtle changes began to shift the balance. Each time an asteroid slammed into Earth, it tugged the larger planet slightly, altering its path. Each time debris struck Theia, it did the same, creating ripples in the fabric of their shared orbit. These nudges were tiny, imperceptible in the moment, but over millions of years they accumulated. The careful distance between Earth and Theia began to shrink. Their once stable harmony began to falter. It was as if two dancers, once perfectly timed, were now stumbling into one another, their steps growing more uncertain, more perilous. From Earth's surface, had there been eyes to see, Theia would have grown brighter in the skies as time passed. At first, it would have been little more than a bright, wandering star, distinct among the backdrop of countless fiery streaks that lit the heavens. But slowly, orbit after orbit, it would have appeared larger, more defined, a glowing sphere that lingered on the horizon like a haunting presence. Earth's skies were already filled with fire from falling debris, yet Theia's steady approach carried a different weight, a different inevitability. It was not just another asteroid to strike and vanish. It was a world, and it was coming closer. The tension between the two planets was not immediate catastrophe, but rather a slow tightening of a cosmic thread. Tidal forces began to stretch Earth's surface. Lava seas swelled higher as Theia's gravity tugged at them. Volcanic eruptions intensified, as though the planet itself sensed the growing presence of its twin. The skies churned more violently, lightning storms doubling in ferocity, the atmosphere shuddering under pressures it had never endured. Earth was unfinished, unstable, and the added strain pushed it further toward the breaking point. For Theia, the dance was equally fateful. Its orbit bent and twisted with each pass, its path pulling ever closer to Earth's. Impacts shook its crust, debris fell into its skies, and its smaller body absorbed each blow with mounting difficulty. The gravitational tug-of-war between the two worlds was no longer a balanced rhythm, but a dangerous spiral, each loop around the sun pulling them toward collision. It is difficult to imagine the moment when inevitability overtook chance, when the two could no longer avoid their meeting. For millions of years, it was still possible that Theia might have drifted away, nudged just enough by another planet or by Jupiter's immense gravity to escape into a different path. But gravity is persistent, and the solar system unforgiving. Step by step, orbit by orbit, Theia's fate was sealed. As the two worlds neared their final approach, the solar system itself seemed to hold its breath. Smaller fragments collided with Earth and Theia in increasing numbers, heralds of the greater collision to come. Each impact sent debris outward, clouds of dust and rock that drifted between the two planets like scattered sparks before a fire. Earth groaned under the strain, its molten mantle shifting violently, its skies darkening with ash. Theia, too, bore the scars of endless impacts, its surface cracked and scarred, as though it too was preparing for what was to come. And then, at last, the dance ended. Theia struck Earth with unimaginable force. It was not a glancing blow, not a gentle meeting, but a catastrophic collision between two worlds traveling at speeds beyond comprehension. The energy released was greater than anything since the birth of the solar system itself. The surface of Earth exploded outward, molten rock and vaporized stone flung high above the planet. Theia itself shattered, its crust ripped apart, its mantle torn asunder, its core plunging deep into Earth's own heart. The ground convulsed. Oceans of lava erupted skyward. The atmosphere itself boiled away in the heat. For a time, Earth was not a planet, but a vast, glowing wound, its surface obliterated, its skies filled with fire. Theia no longer existed as an independent world. Its body was gone, consumed by the planet it had collided with, its essence spread across Earth's mantle and core. What had once been two planets was now one, broken, reshaped, and forever changed. Yet the destruction did not end there. Vast amounts of rock and debris were thrown into orbit, circling Earth like a shroud of fire. This ring of glowing fragments spun around the wounded planet, colliding with one another, breaking apart, reforming. Over time, this chaos would settle, the fragments slowly gathering together under gravity's pull. The collision was the end of Theia, but it was also the beginning of something greater. Earth, though scarred and reshaped, now held within it not only its own materials, but those of Theia. The cores of the two planets fused, strengthening the magnetic shield that would one day protect life from the harsh solar winds. The molten surface of the young Earth continued to churn and flow, its crust fractured and restless. Yet beneath the chaos, a new stability was quietly taking root. Though Theia no longer existed as an independent world, its essence had not vanished. It had merged with Earth, leaving behind hidden traces in the deep mantle, in the elements that would later form oceans, and in the very balance of the planet itself. The violent encounter had reshaped not just the physical body of Earth, but the trajectory of its future. And above the scorched, molten plains, the sky seemed to whisper of more transformations yet to come, hinting at the birth of something that would illuminate the nights and guide the rhythms of life for billions of years ahead. But this union of worlds did not end with the merging of rock and metal. Something even more extraordinary was unfolding in the skies above. The debris thrown outward, glowing and tumbling in orbit, was not just wreckage. It was the raw material for a companion world. Slowly, steadily, gravity began to weave order from chaos. Fragments collided and joined, shattering and reforming, until over countless orbits, a single body emerged from the fire. A new world had been born. The moon, forged in destruction, circled Earth as though it had always been destined to be there. At first, the moon was far closer than it is today. It loomed massive in the skies of the young Earth, glowing red with heat, its surface still molten, scarred by constant impacts from the leftover debris that swarmed around the planet. To any who might have seen it, the sight would have been both terrifying and magnificent. An enormous sphere of fire suspended above a wounded world, reflecting the violence of its birth. Yet in that moment, a profound shift had taken place. Earth was no longer a solitary, chaotic body struggling in the furnace of the early solar system. It now had a partner, and this partner would transform its fate forever. The moon's presence changed everything. Earth's axis, once erratic and unstable, began to steady under the pull of its new companion. Before the collision, Earth's tilt wobbled violently, sometimes shifting so far that the planet might have rolled nearly onto its side. Such chaos would have meant climates in constant flux, ice at the equator, searing heat at the poles, endless instability that would have made the rise of life nearly impossible. But the moon, massive enough to exert its influence, held Earth steady. It anchored the planet, locking its tilt into a balance that has endured for billions of years. From this tilt came the rhythm of seasons, the gentle cycle of change that would one day nurture forests, oceans, and all living creatures. Without the moon, Earth would have been a place of endless turmoil. With it, stability was born. Theia's gift extended beyond stability of tilt. The new moon also gave Earth tides, the eternal rising and falling of the oceans. In the beginning, when the moon was much closer, the tides were enormous, sweeping water far inland and then drawing it back with immense force. Though destructive at first, these tides became a vital engine of change. They stirred Earth's early oceans, mixing minerals and chemicals, creating countless shallow pools where water ebbed and flowed. In these tidal pools, life's first building blocks could be concentrated, tested, and reformed again and again until the spark of biology ignited. The moon's pull ensured that the oceans were never still, never stagnant, but always in motion, always alive. Theia had not just merged with Earth, it had given Earth a partner, a clock, a rhythm. The presence of the moon marked time in ways Earth had never known. The length of days, once wildly variable as Earth spun too fast or too slow, began to stabilize. The moon's gravitational pull acted like a brake, gradually slowing Earth's frantic rotation. Days lengthened, first from just a few hours to 6, then 12, then closer to the 24-hour cycle we know today. This slow, steady rhythm of day and night, tied forever to the moon's pull, would provide the foundation upon which life could grow, adapt, and flourish. Even deeper than tides and tilt, Theia's remnants had given Earth something far more profound. When its metallic core merged with Earth's, it boosted the planet's magnetic field. This invisible shield became one of the greatest protectors of life to come. The young sun was violent, its solar winds blasting the inner planets with streams of charged particles powerful enough to strip away atmospheres and boil away oceans. Mercury and Mars, lacking strong shields, were left barren and exposed. But Earth, strengthened by Theia's sacrifice, held firm. Its magnetic field deflected the solar winds, guarding its skies, ensuring that its growing atmosphere would endure. Without that protection, Earth might have been stripped as bare as Mars. Instead, it became a sanctuary. And within that sanctuary lay another possible gift. Some scientists believe Theia may have brought with it vital elements delivered in the moment of impact. Water, bound within minerals deep in its mantle, could have been released during the collision, adding to Earth's growing oceans. Rare elements, essential for biology, carbon, nitrogen, sulfur, may have been seeded by Theia's shattered form, spread across Earth's molten crust to one day fuel the chemistry of life. In this way, Theia did more than steady Earth or shield it. It may have given Earth the very ingredients that made it alive. The image is haunting, a planet that died to save another. Theia's body was obliterated, its individuality lost, but in its destruction, it gave birth to something greater than itself. It gave Earth stability, rhythm, protection, oceans, and perhaps even the seeds of life. It gave Earth a moon, a companion that has circled us ever since, lighting our skies and shaping our destiny. It is no exaggeration to say that without Theia, Earth would likely not be habitable. Without Theia, we might not be here at all. And so the aftermath of the Great Collision was not only chaos and fire, but also transformation. Earth cooled slowly, its surface solidifying into crust, its atmosphere thickening with vapor that condensed into falling rain. For millions of years, storms raged as the skies poured water onto the surface, filling the great basins carved by impacts and lava flows. Oceans formed, vast and deep, stirred endlessly by the pull of the moon. Volcanic islands jutted from the waters, reshaped again and again by eruptions and quakes. Through it all, the moon looked down, keeping its silent watch, its orbit gradually receding, its influence ever steady. The scars of Theia's impact never truly vanished. Deep within Earth's mantle lie regions thought to be remnants of Theia's body, giant buried fragments that still affect how heat moves within the planet. In our very geology, the fingerprints of Theia remain. Every continent that drifts across Earth's surface, every mountain that rises, every volcano that erupts, these movements are shaped by a planet that no longer exists, yet still endures as part of us. It is almost poetic, this legacy of destruction and creation. A world lost and yet not lost at all. Theia's death was not an end, but a transformation, a sacrifice that turned chaos into possibility. Earth did not become habitable in spite of Theia. It became habitable because of Theia. Every tide that moves, every season that turns, every life that breathes, all are bound to that ancient collision. The moon above us is not merely a satellite. It is a memorial to a fallen world, a reminder of the price that was paid for our existence. Imagine the night skies of early Earth, when the moon was vast and looming, filling the heavens with its glow. Imagine the tides surging across newborn oceans, the rhythm of day and night taking shape, the tilt of the planet finding balance. In those moments, Earth was remade, not by chance alone, but by the sacrifice of another world. Theia's gifts were not gentle. They came through fire, through impact, through obliteration. But without them, Earth might have remained an unfinished world, barren and unstable, just another rocky planet adrift in the solar system. Instead, it became something more. It became a cradle for life. And though billions of years have passed since that collision, Theia's presence is still with us. We see it every time the moon rises over the horizon, every time the tides shift along the shore, every time we measure the turning of the seasons. Theia's death gave us these rhythms, these cycles, these gifts that sustain life itself. Theia may have died, but it lives on in everything we are. Yet the moon, now circling Earth, was not merely a witness to the aftermath. It became a subtle architect of the planet's future. With each orbit, the newborn satellite exerted its gentle, rhythmic pull, tugging at the molten seas and the semi-fluid crust beneath. This tidal dance, imperceptible on a human timescale but monumental across millennia, began to sculpt the surface of Earth in ways that would define the planet's character for billions of years. The violent heat of collision slowly gave way to a cooling, restless world where molten rock began to harden and steam-laden skies slowly thinned as water condensed into nascent oceans. The earliest crust of Earth was fragmented, broken into massive plates that floated atop the still molten mantle. Volcanoes erupted with relentless fury, spewing lava that cooled into jagged mountains and expansive plains. Underneath, magma currents churned constantly, a hidden engine redistributing heat and minerals across the planet. As the surface solidified, it formed a thin but resilient skin, a fragile envelope capable of supporting new and strange processes. Where once there had been only incandescent rock and vapor, pools of water began to accumulate, sheltered in the low basins carved by the chaotic movements of the cooling crust. These oceans were dark and acidic, yet they were alive with possibility. In their depths, minerals dissolved and mingled, creating a chemical richness that would one day seed the very beginnings of life. And above these waters, the moon's tides orchestrated a continuous ebb and flow, moving water across shorelines, stretching pools into shallow bays, and repeatedly exposing and covering the primordial sediments. In these cycles, the first hints of the biological rhythm would emerge, a pattern of wet and dry, of heat and cold, of exposure and protection. Life, if it were ever to emerge, would need such a stage, and Theia's sacrifice had ensured its creation. The stabilization of Earth's tilt by the moon was equally transformative. Whereas Venus had spun erratically, its axis unstable and prone to chaotic shifts, and Mars had wobbled subtly yet left its seasons irregular, Earth's tilt became predictable. This regularity meant seasons that could repeat year after year, nurturing cycles in weather and climate that would later define ecosystems. The combination of a stable axis and the steady pull of the moon's tides created a planetary rhythm that no other nearby world could match. A heartbeat for the future, measured in days and months rather than the chaotic cycles that might have left life struggling to adapt elsewhere. Over millions of years, the oceans deepened, warmed, and slowly began to organize themselves into the vast basins we recognize today. Rain fell from clouds thick with water vapor, carving rivers and lakes into the solidifying crust, redistributing sediments and minerals. The atmosphere, once a churning cloud of gases from the collision, gradually became a more hospitable shroud, balancing oxygen, carbon dioxide, nitrogen, and other elements in a delicate mixture. Winds swept across molten plains and cooling mountains, spreading dust and minerals, stirring shallow waters, and helping to distribute heat. This slow, deliberate organization of Earth's surface was a direct consequence of the collision. Without Theia's impact, Earth might have lacked the stability, mass, and rotational energy to hold an atmosphere in such balance, or to retain water long enough for oceans to take shape. Meanwhile, the moon's influence on tides became an invisible hand guiding the chemistry of early Earth. The constant rise and fall of water moved nutrients between shallow and deep zones, cycling chemical compounds through repeated immersion and evaporation. This action not only shaped coastlines, but also mixed the waters, promoting a diversity of chemical interactions that might never have occurred in still, stagnant pools. Pools alternately flooded and dried, salts concentrated, and minerals precipitated, creating pockets of chemical richness where the first life could one day take root. It is tempting to imagine these tides as a lullaby, a gentle rhythm humming through the ages, quietly preparing the world for what was to come. As Earth cooled, the contrasts between it and its neighboring planets became ever more apparent. Venus, similar in size to Earth but devoid of a stabilizing impact, remained trapped under a thick, suffocating atmosphere of carbon dioxide. Surface temperatures soared, and clouds of acid rain scoured the surface without mercy. Mars, smaller and lighter, could not retain much of its atmosphere and cooled quickly, leaving it frozen and barren, with thin air unable to support liquid water for long. Earth, thanks to the unique combination of mass, tilt, tidal influence, and chemical richness gifted by Theia, found a middle path. Not too hot, not too cold, not barren, but alive with potential. This uniqueness extended beyond mere habitability. The rotation rate of Earth, slightly accelerated by the impact, established a rhythm of day and night that allowed energy cycles to stabilize. Seasons emerged with consistency, enabling climate zones to form and promoting weather patterns that would later support an intricate web of life. Volcanic activity continued, yet it became regulated by the solidifying plates, providing minerals to the surface while also driving the recycling of materials into the deep mantle. It was a delicate dance of forces, all initiated by an event that seemed catastrophic in its moment, but ultimately foundational for everything that followed. Throughout this long period of transformation, Earth's surface continued to bear the mark of Theia. Deep within the mantle, traces of Theia's composition mixed with Earth's original material, enriching the planet with heavy elements that might have been otherwise scarce. These elements played a role in the magnetic field, the geothermal heat, and the chemistry of oceans and atmosphere. Without this mixture, the protective shield against solar radiation might have been weaker, and the water and life-friendly elements less abundant. In this sense, every drop of rain, every ocean current, and even the stones beneath the feet of future life forms carried the silent memory of a planet that no longer existed as a separate body. As millions of years passed, the moon's orbit slowly increased, moving it farther from Earth, but its influence remained profound. It continued to stabilize the tilt, control tides, and shape the cycles of day and night. Earth's oceans, once violently churned by collision, now flowed in grand currents, distributing heat and nutrients around the globe. Shallow tidal pools became incubators for chemical reactions, stirring the ingredients of life and creating the gradients necessary for molecules to combine and recombine in complex ways. The planet, once a chaotic fireball, was slowly becoming a dynamic, living system, capable of sustaining processes that could one day lead to life. In imagining the planet's transformation, it is also revealing to look outward. Venus and Mars, despite their proximity and initial similarity, lacked the same circumstances that Earth had gained. Venus, with no moon of sufficient mass, could not stabilize its tilt. Its atmosphere remained a furnace, and any early water would have boiled away. Mars, smaller and more fragile, suffered atmospheric loss and cooling that left it barren and frozen. Earth, by contrast, retained its water, its atmosphere, and a stable climate, all inextricably linked to the moment a lost planet intervened and reshaped its destiny. This comparison highlights the subtle but profound ways in which Theia's impact was not merely a collision, it was a gift, an opportunity for life that no other nearby planet could claim. The story of Earth's evolution in these early epochs is one of patience and gradual transformation. The fiery aftermath of collision gave way to cooling and solidification. The moon's tidal pull organized water and chemistry. The crust stabilized, rivers and oceans formed, and the atmosphere became breathable over millions of years. And all of this was framed by the cosmic shadow of a lost world, a twin planet whose destruction allowed Earth to exist in the form we recognize today. Without Theia, the planet might have remained too chaotic, too unstable, too barren for life to ever emerge. And so, as billions of years unfolded, Earth moved steadily toward habitability. The oceans became permanent fixtures, the atmosphere balanced, the day-night cycles regular, and the climate zones stable. Tides continued to sweep across coastlines, promoting chemical interactions that nurtured the precursors of life, the very conditions that would allow microscopic life forms and eventually the complex web of life, including humans, were directly tied to the event that occurred in a brief, violent instant billions of years ago. In this way, Theia's story persisted long after its physical form was gone. The moon, tides, axial stability, elemental enrichment, and chemical diversity all bore witness to a sacrifice written in cosmic proportions. The consequences of that single fateful collision continued to unfold quietly, shaping the planet's character and establishing a rhythm of cycles, seasons, and processes that would support life for eons to come. It is a humbling thought. Every river that flows, every wave that crashes, every season that changes, every breath of air we take carries within it the legacy of a lost planet. Earth's unique habitability, its oceans, its climate, and its potential for life are all gifts from a world that no longer exists, yet whose presence is felt in every corner of our planet. In tracing this chain of consequences, it becomes clear that Earth did not simply survive the chaos of the early solar system. It was shaped, guided, and ultimately made ready for life by an extraordinary series of events, with Theia at the center. And so, as we look at the planet today, we are inextricably linked to a story written not in human timescales, but in cosmic ones, a story that began with a lost planet whose death became the seed of all that would follow. The story of Theia might feel singular, almost too extraordinary to imagine happening more than once. A single rogue planet, wandering across the inner solar system, collides with Earth, disappears, and yet lives on through the moon, the tides, and the delicate stability of our world. It is a story so powerful it can feel like a one-time miracle. But in truth, Theia was not alone. The early solar system was filled with worlds like it, half-formed planets, wandering embryos of rock and ice, each with its own potential future. Some merged into the great planets we know today, while others were shattered, forgotten, or reduced to scattered rubble. Theia's sacrifice gave us the Earth we know, but hidden within the quiet expanse of space are clues that other lost worlds once roamed. Their stories remain fragmented, yet they remind us that Earth's survival was not guaranteed. Instead, it was the outcome of a cosmic lottery, where countless players never lived long enough to leave a legacy. As we trace the shadows of these forgotten worlds, we begin to see a broader truth. Theia's story is not only about one lost planet. It is about a time when the solar system itself was young and wild, sculpted through violence, chance, and sacrifice. To step back into this era is to imagine a very different kind of solar system. Today, when we look outward from Earth, we see a tidy arrangement. The rocky worlds of Mercury, Venus, Earth, and Mars lined up close to the Sun. A gap filled with asteroids. Then the massive gas giants, ringed and orderly, circling further out. The view seems calm, almost architectural, as if designed with symmetry in mind. But this modern serenity is deceptive. 4.5 billion years ago, the solar system was anything but orderly. It was a crowded nursery of planets in the making, a place of chaotic movement where dozens, perhaps even hundreds, of planetary embryos jostled for space. These were not small bodies either. Many were as large as Mars, some approaching the size of Earth itself. They wandered in unstable orbits, tugging and colliding with each other, their fates determined by gravity, momentum, and sheer chance. The Earth we live on was only one of these players. It began as a growing sphere of rock, accumulating material through countless impacts. Every embryo sought to grow larger, sweeping up dust and debris, merging when collisions were slow, shattering when they were violent. The result was a dangerous, unpredictable environment, more akin to a demolition derby than the calm clockwork we see today. It was in this crowded stage that Theia emerged. Yet Theia was only one of many. The most fortunate embryos merged peacefully into the worlds we know. Earth itself is the sum of uncountable collisions, its mass built layer by layer from the wreckage of smaller worlds. Venus, nearly Earth's twin in size, was sculpted by similar processes. Even Mercury and Mars, though smaller, bear the hallmarks of having survived this turbulent time, stripped or stunted by the violence of their encounters. Some were shattered entirely, leaving behind only fragments. These fragments may still circle the sun today, hidden in the asteroid belt or as scattered populations of minor planets. Others were absorbed so completely into larger bodies that not even a trace of their individuality remains, their cores sinking silently into the growing hearts of the planets we now know. Still others may have been ejected outright, flung into interstellar space, cast adrift as lonely wanderers between the stars. For every Earth, there may have been many Theias, embryos that grew large enough to matter, but not large enough to last. Their stories ended in destruction, yet their material lives on, recycled into new forms. If we look closely, the asteroid belt between Mars and Jupiter may be one of the clearest memorials to these lost worlds. At first glance, the belt looks like a planet that never formed, a jumble of rocky debris too small to coalesce. For decades, scientists wondered, was there once a fifth rocky planet here, destroyed and broken apart? Modern understanding tells us that Jupiter's enormous gravity prevented such a planet from ever assembling. Every time debris in that region tried to come together, Jupiter's pull tore it apart again, keeping the belt as a graveyard of fragments. Yet hidden within those fragments may be pieces of lost embryos, remnants of worlds that once tried to grow but never found stability. Ceres, the largest body in the belt, hints at this. At nearly 600 miles across, it is large enough to be spherical, almost planetary in form. But it is only a shadow of what might have been. Had conditions been different, the asteroid belt could have birthed a true planet, perhaps rivaling Mars in size. Instead, it stands as a monument to opportunity lost, a non-Theia, a world that might have been but never was. Even more intriguing is the possibility of ejected planets. The early solar system's violence did not only create impacts, it also threw bodies outward at incredible speeds. A close pass by Jupiter or Saturn could fling a planetary embryo into interstellar space, stripping it from the Sun's family forever. Imagine, then, the possibility, countless Theias drifting in the cold between the stars. They are invisible to us now, wandering in silence, carrying within them all the potential of worlds that never found a home. These orphan planets remind us that the solar system we see is not complete. It is the survivor's version of what once was, trimmed down from a far more crowded beginning. Some astronomers suspect that rogue planets may be common throughout the galaxy. The solar system may have given birth to several of its own, now long gone. In this sense, Theia was unusual not for existing, but for leaving behind a legacy we can still trace. Most lost worlds, by contrast, have vanished without a story. This raises an intriguing possibility. Was Theia unique, or could there have been other such collisions, other sacrifices we cannot easily see? The answer is both humbling and unsettling. The very growth of the planets required such collisions. It is likely that many Earth-sized worlds were assembled through catastrophic impacts, with earlier versions of Theia striking Venus, Mars, and even Mercury. We may simply lack the direct evidence. Consider Mercury. Its metal-rich core makes up an unusually large fraction of its mass. One explanation is that a massive impact stripped away much of its rocky mantle, leaving behind a dense iron world. If true, then Mercury too may carry the ghost of a lost Theia, a hidden story of collision and transformation. Venus and Mars show similar mysteries in their geology and atmospheres. Their pasts are not as clear as Earth's, but subtle signatures suggest they too were sculpted by impacts we can no longer fully reconstruct. Theia's story is visible to us because of the moon, a constant reminder in our night sky. Other lost worlds may have left no such monuments, their stories buried beneath the surface or erased entirely. What emerges from these shadows is a profound sense of fragility. The Earth we know exists because one lost planet struck at just the right moment, in just the right way, leaving behind a stable, habitable world. Countless others did not. They were absorbed, shattered, or exiled into the void. Theia's sacrifice stands out not because it was unique, but because it endured. Without the moon, without Earth's tilt, without the tidal rhythms and elemental gifts, our planet might have been just another failed experiment in the solar system's crowded beginning. When we imagine the early solar system, then, we must not see a tidy sequence of planets. We must see a battlefield, a stage littered with wreckage, where survival was rare and loss was the norm. As we reflect on these forgotten worlds, a quiet question lingers. How many Theias might there have been? How many planets were sacrificed in silence, leaving no trace but scattered fragments or whispers in the chemistry of the worlds we know? Theia was not alone. It was part of a larger story, a chorus of lost planets whose songs have mostly been silenced. Yet in those silences, we can imagine a truth, that our Earth, stable and alive, is not inevitable. It is one outcome among countless others, shaped by sacrifice and chance. And so, from the legacy of a single lost world, we now widen our gaze. The solar system is full of ghosts, shadows of planets that never were. To follow their traces is to uncover not only what might have been, but also to recognize how rare and precious our own survival truly is. In Theia's story, we find both intimacy and grandeur. A lost planet whose memory is written in our tides, our seasons, and our skies. Yet beyond Theia lie the whispers of others, fragments scattered across the solar system, silent wanderers between the stars, or hints buried in planetary mysteries. These are the shadows of other lost worlds, reminders that Earth's survival was not guaranteed, and that its habitability was carved from the wreckage of a violent beginning. And as we step forward, we must ask, if Earth's story was shaped by sacrifice, what stories do the other planets hold? What secrets lie in the asteroid belt on Mars's frozen plains, or within the suffocating skies of Venus? These questions will guide us onward into the stories of our planetary neighbors, worlds that, like Earth, once carried the promise of habitability, but whose paths diverged into other fates. The questions linger like echoes in the vast silence of space. If Earth's story was shaped by sacrifice, what stories do the other planets hold? What secrets lie in the asteroid belt, on Mars's frozen plains, or within the suffocating skies of Venus? As the mind drifts outward, away from Earth and its loyal moon, the gaze falls upon another mystery, one written not in the memory of tides or seasons, but in a scattered trail of stone and dust. It is a region of space that feels unfinished, as though the universe began to sculpt a world there, but then set down its tools and left it incomplete. Between Mars and Jupiter lies the asteroid belt, a band of rubble circling the sun like a broken ring. To the casual eye, it might appear unremarkable, a scattering of rocks too small and too distant to hold significance. Yet in reality, this belt holds within it the ghost of a world that never came to be. It is in many ways the cemetery of a planet that never was. The early solar system was not a place of order and stillness, but of turbulence and violence. Planets did not appear fully formed, nor did they emerge from the nebula in neat, stable orbits. They were born from collisions and chaos, their paths shaped by chance encounters and the inexorable pull of gravity. Just as Theia once circled Earth before their fateful meeting, so too did countless other planetary embryos wander the newborn solar system. In the region now occupied by the asteroid belt, the raw material for a planet was certainly present. Dust, gas, and rock swirled together, colliding, clumping, and growing, just as they had in the regions where Earth, Mars, and Venus were taking shape. By all accounts, There should be another planet between Mars and Jupiter. But when we look there, we find no such world, only fragments, broken remnants of something that tried to form but failed. The reason for this failure lies with Jupiter, the giant of the solar system, vast enough to swallow more than 1,000 Earths, loomed nearby. Its gravity was overwhelming, its presence impossible to ignore. As material in the belt region began to coalesce, Jupiter's pull constantly disrupted it. Small clumps of rock that tried to grow into larger bodies were tugged out of place, flung into chaotic orbits, or shattered by the gravitational resonance that echoed through the region. It was as though the solar system itself had set aside this patch of space, refusing to let it ever find peace. The belt became a graveyard of beginnings, a place where a planet might have been born but never was. Imagine, for a moment, if Jupiter had been farther away, or less massive. The material in the asteroid belt might have been left undisturbed, allowed to gather into a coherent world. Over millions of years, those countless fragments of rock and metal could have merged into a planet perhaps as large as Earth or Mars. A new neighbor might have stood in the solar system, occupying the space between Mars and Jupiter, following its orbit in calm stability. What kind of world might it have been? Would it have been rocky, like Earth and Mars, or icy and volatile like the outer planet's moons? Would it have carried water, perhaps even the ingredients for life? These are questions that remain unanswered, yet they open a door to imagination, to a vision of a solar system that might have looked very different from the one we know. The asteroid belt we see today is a faint shadow of this possibility. To many, it might seem empty because its total mass is surprisingly small. Though the belt contains millions of individual asteroids, their combined material is less than a third the mass of Earth's moon. Even Ceres, the largest body in the belt, is only about a quarter the size of our moon. Yet these pieces, scattered though they may be, are fossils of planetary formation. Each asteroid is a fragment of a process interrupted. Some are pristine, unchanged since the earliest days of the solar system, carrying within them the untouched chemistry of creation. Others are shattered remnants of larger bodies that once tried to assemble before being broken apart again. Together, they tell a story of ambition cut short, of a world that hovered on the edge of existence but never crossed into being. It is a strange thought. While Earth was colliding with Theia, giving birth to the moon and shaping its destiny, another region nearby was being denied its own chance at destiny. The same forces of accretion and collision that created our planet were at work in the asteroid belt, but where Earth succeeded in becoming whole, the belt remained forever broken. In this sense, the asteroid belt is the inverse of Theia's story. Theia was a planet that lived and died, its body sacrificed so Earth might thrive. The belt, on the other hand, never even reached the stage of being a planet. It was a story cut off before it could truly begin, an unfinished chapter in the cosmic narrative. Jupiter's role in this cannot be overstated. Its gravity not only prevented a planet from forming, but also shaped the structure of the belt itself. There are gaps where no asteroids exist, carved out by the resonances of Jupiter's orbit. These empty regions, known as Kirkwood gaps, are like scars left behind by the giant planet's influence. They are silent reminders of how power can shape destiny, not only for worlds that exist, but also for those that never had the chance. In this way, the asteroid belt stands as proof that the history of the solar system is not just about creation, it is also about prevention. Some worlds were not destroyed, they were simply never allowed to form. And yet, even in its incompleteness, the belt has played a role in Earth's story. Fragments from the belt have often found their way to us, pulled by Earth's gravity as meteors that streak across our skies. Some of these impacts have been catastrophic, reshaping life and altering the course of evolution. Others have delivered valuable ingredients, including water and organic molecules, the building blocks of life itself. In this way, the planet that never was still reached across space to touch the planet that is. The asteroid belt, though denied its chance to be a world of its own, has left fingerprints on Earth's past, and, perhaps, on life itself. Consider also the possibility of what might have happened if a planet had indeed formed there. Between Mars and Jupiter, such a world would have been close enough to the Sun to be warm, yet distant enough to carry large reserves of water ice. If it had grown massive enough, it might have maintained a thick atmosphere. Could it have harbored oceans, continents, and perhaps even life? We can only speculate, but the thought is compelling. Perhaps in an alternate solar system where Jupiter was less dominant, there might have been two habitable worlds, Earth and its neighbor in the belt, each evolving separately, each carrying its own story of life. Perhaps we would not look to Mars for the dream of a second home, but to this lost world that never was. The asteroid belt also invites us to reflect on chance. Why did Earth succeed while this region failed? Why was our planet allowed to thrive, to collide with Theia, and inherit the gifts that would one day support life, while the belt was left barren? These are not merely scientific questions. They are philosophical ones, questions that touch on the nature of existence itself. Our presence here, listening to the echoes of these lost worlds, is not just the result of Earth's survival. It is also the result of countless others' failures. The asteroid belt is a monument to those failures, a silent reminder that the road to habitability is narrow and most attempts fall short. As we trace the fragments in the belt, we see diversity among them. Some are carbon-rich, dark, and primitive, holding within them the chemistry of the early solar system. Others are metallic, gleaming reminders of cores that never became planets. Still others are stony, fractured, shaped by impacts that shattered larger bodies. Together, they form a mosaic of possibilities, each one a sliver of a path not taken. They are not just rocks. They are the bones of a planet that never lived, scattered like ashes around the sun. In a sense, the asteroid belt is haunting. It is like walking through the ruins of an ancient city, where foundations remain but the walls and roofs were never built. You can see what might have been. You can imagine the structure rising from the ground, but it remains forever unrealized. The belt gives us a glimpse into an alternate history, one where the solar system carried an extra planet, and where Earth might not have been alone in its journey. But it is also a reminder that not all beginnings lead to endings, and not all seeds grow into trees. Some remain scattered, never to take root. This realization deepens our appreciation of Earth's path. Our planet was not destined to be what it is. Its success depended on countless delicate balances, its distance from the sun, its collision with Theia, its retention of water and atmosphere, and the stability provided by the moon. Any of these could have gone differently. Earth might have ended up like Mars, cold and barren, or like Venus, hot and suffocating. Or, like the asteroid belt, it might never have fully formed at all. That it did is extraordinary, and that it became habitable is even more so. In this light, the asteroid belt becomes part of our own story, not as a failed world unrelated to us, but as a contrast that highlights just how precarious and rare Earth's success truly was. And so, the belt circles on, year after year, century after century, silently orbiting the sun as it has for billions of years. It is easy to dismiss it as a cluttered region of space, a hazard for spacecraft or a source of shooting stars. But when we look deeper, we see in it a mirror of the solar system's early struggles. We see in it the ghost of a world that never lived, a reminder that not all planets are born and not all stories are told. Its fragments whisper to us, telling us that creation is not guaranteed and that even in the abundance of material and energy, failure is always possible. Yet failure, too, has meaning. Without the asteroid belt's constant supply of impacts, Earth's history might have been different. Some scientists believe that the delivery of water and organic compounds from asteroids was crucial to Earth's development. If true, then even the failed planet played its part in our survival. It may never have existed as a world, but in its scattered remains, it contributed to the emergence of life on the one that did. In this way, the belt is not only a monument to failure, it is also a quiet benefactor, a reminder that even in loss, there can be gifts. As we leave behind the scattered stones of the asteroid belt, we are left with a humbling thought. The solar system is not a perfect arrangement of planets, but a tapestry of successes and failures, of worlds that lived, worlds that died, and worlds that never were. Each carries lessons, and each shapes the story of our existence. From Theia's sacrifice to the belt's unfulfilled promise, we are reminded that our place here is fragile, contingent, and precious. The asteroid belt, like Theia, is part of that story, its silence speaking as loudly as Theia's fiery end. And as we look deeper into the mysteries of our neighboring worlds, we carry with us the awareness that we walk a narrow path through cosmic possibility, one that could so easily have been otherwise. The asteroid belt leaves us with a haunting reminder that not every attempt at creation results in a living world. But sometimes, the cosmos allows a planet to form, gives it a beginning rich with promise, and then quietly withdraws its support before that promise can be fulfilled. If the belt represents a world that never was, then Mars represents a world that almost was. Mars is often called Earth's stunted twin, a planet that, in its youth, bore striking similarities to our own world. In its valleys and dried riverbeds, we see traces of flowing water. In its mineral composition, we detect the fingerprints of ancient chemistry once touched by warmth and moisture. In its frozen poles, we find the remnants of what might have been seas, perhaps even oceans. For a time long ago, Mars wore a face not so different from Earth's. And yet, somewhere along its path, the red planet faltered. Unlike the asteroid belt, which was prevented from ever becoming a planet at all, Mars was born, shaped, and given its chance. It grew in size, accumulated atmosphere, and likely nurtured lakes and rivers beneath a softer, thicker sky. But it froze too soon. Its small size could not sustain the inner fire needed to power its magnetic field, and without that shield, its atmosphere thinned. The solar wind, relentless and unyielding, stripped it away grain by grain until the air that once wrapped the planet became only a whisper of what it had been. The rivers dried, the seas vanished, and the surface hardened into rust-red deserts. When we look at Mars today, we see a landscape of silence. Its mountains are immense, its canyons vast, but its vitality is gone. Olympus Mons, the largest volcano in the solar system, rises 3 times higher than Mount Everest, yet it has been dormant for millions of years. Valles Marineris stretches across a distance longer than the United States, yet no rivers carve its walls, no rains wash its floors. Mars is a planet of grandeur without growth, a reminder that scale alone does not guarantee survival. And yet, it is precisely in this failure that Mars teaches us something profound about Earth. For Mars's early trajectory was not so different from ours. It, too, may have had the ingredients for habitability, warmth, water, and chemistry. But where Earth's story unfolded into flourishing life, Mars's story narrowed into stillness. The difference, in part, came down to chance, size, position, composition, and the unseen hand of planetary fate. Some scientists believe that had Mars been slightly larger, it could have retained its atmosphere. With a stronger gravity, it could have kept hold of the gases that now drifted away. Its magnetic field might have lasted longer, protecting it from the solar wind. In such a case, Mars might have remained warm and wet for billions of years. Perhaps rivers would still flow today, carving new channels. Perhaps life might have arisen there as it did on Earth. Perhaps we would not look across space at a silent red desert, but at a sister world, alive with forests, seas, and skies. But that is not the story we received. Instead, Mars remains a stunted twin, frozen in a state of arrested development. Its failures highlight Earth's precarious success. Our magnetic shield still holds, our atmosphere remains thick, our oceans endure. Yet we know now that these gifts are not automatic. They are contingent, fragile, subject to forces that could easily have tipped us toward a Mars-like fate. Theia's impact, Earth's size, our distance from the Sun, all of these balanced factors made us resilient where Mars was vulnerable. As we study Mars, we are drawn into the delicate balance of habitability. It reminds us that planets are not just rocky spheres orbiting stars. They are systems, finely tuned, whose futures depend on a web of interlocking conditions. Alter one thread, and the whole fabric can unravel. Mars shows us what happens when those threads snap, when size and shield and distance fail to hold together the possibility of life. And yet, even in its failure, Mars whispers possibilities. The ancient riverbeds suggest that life might once have sparked there, however briefly. If it did, it might still linger, hidden deep beneath the surface, sheltered from radiation and cold. The search for Martian life is not only a search for biology, it is a search for understanding what life requires, how fragile it is, and how rare its flourishing might be. In this way, Mars becomes both a warning and an invitation. A warning of how thin the line between success and failure can be. An invitation to imagine what might have been, and to recognize what we have. Earth and Mars, born of the same cosmic nursery, set on similar paths, yet diverging so profoundly, remind us that chance shapes destiny as much as chemistry and physics do. When we walk the deserts of Earth and gaze at our own canyons, we might glimpse something of Mars's silence. When we study the drying of lakes, the retreat of glaciers, or the thinning of atmospheres, we see reflections of what once unfolded there. Mars's story is not only its own, it is also a mirror, showing us what Earth could become and what it once might have been. And so, as we continue our journey outward through the solar system, Mars stands before us not only as a neighbor, but as a lesson. A reminder that habitability is not guaranteed, that the same processes that allow life can also take it away, that for every Earth there may be a Mars waiting silently in the shadows, telling a different version of the same beginning. And yet, Mars was only one thread in the vast tapestry of the solar system, a single variation on a theme that might have been repeated countless times. While its frozen deserts whispered caution, another neighbor loomed with a different tale, a world almost as familiar to us as our own, yet profoundly unlike the planet we call home. Venus, Earth's sister in size, composition, and original placement in the solar system, charted a path that diverged sharply, its story shaped by forces both subtle and immense. It is a story that begins not with ice and riverbeds, but with fire and suffocating heat, a tale of a world that might have been Earth's mirror, but instead became a warning. From the vantage of space, Venus might seem similar to Earth at first glance. Its diameter is only slightly smaller, its mass comparable, its composition rich in silicate rock and metals, a close cousin to our own sphere. In the early days, before the solar system had fully settled into the rhythm we know today, Venus might have held oceans, rivers, and clouds akin to those that eventually graced Earth. It might have even harbored the conditions necessary for life to spark, if only briefly. But what makes Venus remarkable is not its initial promise, but the stark divergence from that promise, the subtle shifts that tipped it toward a different fate. Unlike Earth, Venus lacked the stabilizing influence of a massive moon. Where Theia had collided with Earth, gifting it a companion world whose gravitational pull would regulate tides, stabilize the axial tilt, and foster a rhythm of seasons, Venus remained solitary. Its rotation, slow and unusual, became unstable over time. Without a satellite to help moderate its axial wobble, the planet's tilt likely shifted unpredictably, disrupting any seasonal cycles that might have emerged. In those early centuries, even minor variations in tilt could have profound consequences, influencing atmospheric circulation, surface temperatures, and the retention of volatile elements. Without this stabilizing hand, Venus's climate teetered on the edge of chaos, sensitive to the smallest perturbations. The atmosphere of Venus evolved in ways that stand as a testament to what can happen when these cosmic balances are absent. While Earth retained a moderate climate, a breathable atmosphere, and oceans that reflected and absorbed sunlight in harmony, Venus's skies thickened with carbon dioxide. Without oceans large enough to sequester CO2, and without Theia's contribution to Earth's magnetic and chemical shields, Venus's atmosphere grew dense and oppressive. Sunlight, trapped within this greenhouse of gases, warmed the surface relentlessly, amplifying the heat with each passing millennium. The planet's surface, once potentially habitable, transformed into a furnace, molten rock scorched by the unrelenting blaze of a runaway greenhouse effect. Sulfuric clouds gathered high above the thick atmosphere, reflecting sunlight back into space, yet holding enough heat below to maintain unimaginable surface temperatures. Any water that might have existed in the early days, vapors escaping from volcanic activity or comets, was stripped away, broken apart by ultraviolet radiation, its hydrogen lost to space. The oceans that had been promised never formed, or if they did, they boiled away long before they could settle. Venus became a world where pressure and heat conspired to create a surface beyond the tolerance of any life we know. It is here, in Venus's extreme conditions, that we begin to grasp the extraordinary delicacy of Earth's habitability. Mars, frozen and dry, demonstrated the fragility of sustaining liquid water in a cold, thin atmosphere. Venus, scorched and suffocating, demonstrated the opposite, the fragility of remaining cool and stable under a sun that poured energy without mercy. Earth, in the middle, found balance. Its oceans, atmosphere, and axial tilt, gifts from Theia and fortuitous chance, allowed it to stay within the narrow window where life could emerge and persist. Theia's sacrifice, billions of years ago, echoes here in the contrast, reminding us that one collision, one celestial intervention, can pivot the fate of a planet entirely. But Venus's story is not just a tale of absence or misfortune. It is a record of what might have been, an alternate path that highlights the delicate interactions that govern planetary systems. The massive volcanic plains, the towering mountains, and the rolling highlands all speak to a world that once had the potential to mirror Earth's own early landscapes. The planet's internal heat drove tectonic activity, reshaping its crust, releasing gases, and attempting to create cycles of renewal. Yet without the external stabilizations, the moon's gravitational rhythm, the chemical balance delivered by Theia, these processes spiraled out of harmony, accelerating the extremes rather than tempering them. As we imagine this Venus, we are reminded of the countless what-ifs in the story of our solar system. What if Theia had missed Earth entirely? What if Earth had no moon? What if Venus had received Theia's impact instead? Each alternate scenario yields a planet far different from the one we inhabit, reinforcing the precarious nature of life and habitability. Earth's path, so often taken for granted, is revealed as a rare alignment of circumstances where destruction created opportunity and chaos yielded stability. The lessons of Venus extend further when we consider its magnetic field, or the lack thereof. Earth's molten core, stirred and strengthened by Theia's impact, generates a magnetic shield that protects the surface from solar winds and cosmic radiation. Venus, without this benefit, is exposed to the sun's charged particles, which gradually strip away lighter elements from the atmosphere, modify chemical compositions, and contribute to the planet's infernal surface conditions. In Earth's favor, Theia's collision enriched the planet internally, producing not just the moon, but a dynamic core capable of sustaining life-protecting magnetic forces. Venus remains a stark illustration of how different the balance of chance, chemistry, and cosmic events can be on neighboring worlds. And yet, even in its suffering and extremes, Venus holds fascination. Its thick clouds and glowing haze conceal mysteries, hints of volcanic activity that may still shape its surface. Its atmosphere, though hostile, contains clues to the planet's evolution, chemical cycles, and lost water. Scientists studying Venus do not see a dead world alone. They see a mirror, a cautionary reflection of Earth's early fragility, a lesson in what is possible when stabilizing events do not occur. The planet reminds us that habitability is not a given, that every breath we take, every drop of water, every temperate season is owed to precise cosmic choreography billions of years in the making. We might even extend this reflection further into the imagination. If life had emerged on Venus before the runaway greenhouse set in, it would have been isolated, extinguished, or forced into adaptations we cannot imagine. Microbial life in subterranean caves, fleeting cycles of oceanic activity, or chemical interactions that might have triggered evolutionary beginnings. All of these remain speculation, a tantalizing reminder of the possibilities that were denied. Earth, in contrast, benefited from the convergence of impacts, axial stability, and chemical balance, allowing life to flourish where it might not have had the same circumstances elsewhere. In contemplating Venus alongside Mars, we see a spectrum of planetary outcomes, a set of contrasts that highlights Earth's precarious yet fortunate position. Mars shows us the dangers of early freezing and atmospheric loss. Venus shows us the hazards of heat, chemical imbalance, and unmoderated solar influence. Earth occupies a narrow window between these extremes, a window that Theia's presence helped to define. It is a sobering meditation on contingency, one that encourages both wonder and humility. The story of Venus, like that of Mars, is not static. Geologic and atmospheric processes continue to evolve, even in extreme conditions. Volcanic resurfacing, atmospheric circulation, and solar interactions slowly reshape the planet. These processes unfold on timescales far beyond human perception, yet they are vital for understanding the trajectory of Earth-like worlds. Each piece of data collected, each satellite image, each measurement of pressure and temperature contributes to a deeper comprehension of why Earth survived where its neighbors faltered. As we reflect on Venus and Mars together, we are confronted with the rarity of habitable conditions. The solar system, once teeming with planetary embryos, collisions, and potential worlds, now presents us with stark contrasts. Some planets froze, some burned, and a precious few retained the balance necessary for life. Earth's story, intertwined with Theia's sacrifice, is revealed as the product of a delicate sequence of events, a cosmic alignment that permitted stability, oceans, atmosphere, and eventually life itself. And so, as our gaze stretches from Mars to Venus, we recognize that our planet's fortune is neither random nor trivial. It is the result of violent beginnings, fateful encounters, and ongoing interactions that have nurtured a delicate balance. In this light, every river, every season, every ocean current becomes a testament to cosmic contingency. Earth's habitability is a story written not in human terms, but in the measured, deliberate language of celestial mechanics, collisions, and chemical transformations. Looking outward, we begin to appreciate the rarity of habitable zones, the narrow sweet spots around stars where conditions may allow liquid water, stable climates, and protective magnetic fields. Venus, scorching and unwelcoming, exemplifies a world that strayed too close to danger. Mars, frozen and retreating, exemplifies a world that drifted too far. Earth, suspended in its precise orbit, blessed by a lost companion planet, exists in the delicate middle ground, a reminder that life is never guaranteed, and that the stories of other worlds teach us as much about ourselves as they do about them. From these reflections, we can anticipate the next chapter in our exploration. Beyond Venus and Mars lie the outer planets, smaller icy bodies, and countless debris fields, each a repository of cosmic history. The solar system is not just a collection of worlds. It is a dynamic arena of possibilities, successes, and near misses. Earth's fragile existence, nurtured by Theia, is a central note in this symphony of chance. And as we prepare to trace the stories of other distant worlds, we carry with us the awareness that for every Earth, there may be countless alternate outcomes, some burned, some frozen, some lost entirely to the void. As we lift our gaze beyond the immediate neighborhood of Venus and Mars, the story of Earth becomes even more extraordinary. We are reminded that our planet did not emerge in isolation, nor did it flourish merely by chance. The early solar system was a violent theater of collisions, wandering planetary embryos, and scattered fragments of rock and ice. Within this tumult, each orbit, each gravitational nudge, and each collision carried consequences that rippled through millions of years, shaping the planets and determining their fates. Earth's delicate balance, forged by the violent embrace with Theia and tempered by chance, stands as a rare anomaly in a system defined by chaos. To understand this rarity, we must think in terms of habitable zones, often called the Goldilocks zones, where conditions are neither too hot nor too cold, neither too hostile nor too barren, where water can remain liquid and climates can stabilize long enough for life to take hold. Around our sun, Earth sits within this narrow range, far enough from the searing heat that makes Venus a furnace, yet close enough to avoid the frigid reaches that left Mars frozen and retreating. It is a delicate positioning, the result of chance, cosmic dynamics, and, as we have seen, the dramatic intervention of a lost planet whose death shaped the very axis, tides, and oceans that allow our world to sustain life. Yet, even within this seemingly perfect orbit, Earth's stability is far from guaranteed. Small shifts in distance, slight variations in planetary mass, or the absence of the moon would have altered the course of our history. Without the stabilizing influence of Theia's remnants, the tilt of Earth's axis might have varied chaotically, leading to wild, inhospitable seasons, violent climate swings, and the collapse of oceans. Without a magnetic field strengthened by the fusion of Theia's core, solar winds might have stripped away the atmosphere over eons, leaving a barren, airless world. Every factor, from orbital eccentricity to axial tilt, plays a role, creating a chain of dependencies that highlight the fragility of habitability. As we step back and consider the scale of the galaxy, this fragility becomes even more striking. Our Sun is one of hundreds of billions of stars in the Milky Way alone, each with its own entourage of planets and debris. Observations of exoplanets have revealed an astonishing diversity: worlds of molten rock, gas giants with crushing pressures, icy planets far from warmth, and those in precarious orbits around variable stars. Yet among this multitude, few appear capable of sustaining life as we understand it. The fraction of planets that occupy stable habitable zones with the right size, composition, distance, and protective mechanisms is vanishingly small. Earth is not only fortunate within the confines of our solar system, it is exceptional in the cosmos at large. The idea of habitable zones also reminds us that the presence of liquid water, often seen as a prerequisite for life, is a condition fraught with complexity. Water itself is fragile. Too close to a star, and it evaporates into the atmosphere, accelerating runaway greenhouse effects. Too far, and it freezes, halting the processes that could nurture life. The interactions between water, atmosphere, and planetary rotation are subtle yet decisive. Theia's collision, in particular, influenced the distribution of water, the creation of tides, and the stabilization of Earth's rotation, making possible a delicate dance that allowed oceans to persist, climates to moderate, and continents to emerge from molten beginnings. Beyond our immediate system, the scale of potential habitable worlds diminishes even further. Across the galaxy, many stars are smaller and cooler than our Sun, some larger and far more volatile. Planets in these systems often face extreme variations in radiation, frequent stellar flares, or unstable orbits caused by nearby companions. The specific combination that allowed Earth to not only form but maintain the conditions necessary for life may be extraordinarily rare. Each element of stability we observe today, the moon's pull, the axial tilt, the protective magnetosphere, is the result of precise cosmic choreography, a choreography that may be replicated elsewhere, only in the rarest of circumstances. Even within Earth's own history, we see how tenuous this balance can be. Ice ages, massive volcanic eruptions, asteroid impacts, all threaten the fragile equilibrium that allows ecosystems to persist. Yet in all these challenges, the foundational gifts of Theia and the stabilizing role of the moon, the moderate orbit, and the protective atmosphere have allowed life to endure. Without these gifts, the consequences of otherwise manageable events might have been catastrophic. Earth's story is not one of guaranteed success. It is a record of survival, of resilience, and of the precise alignment of conditions that permitted complexity to emerge from chaos. Looking deeper into these dynamics, it becomes clear that Earth's habitability is tied to an intricate network of planetary interactions. The moon, still glowing faintly from its molten birth, exerts a gravitational pull that stabilizes Earth's rotation, moderates axial wobble, and drives tides that circulate nutrients through oceans. Tides are more than rhythmic motions. They are mechanisms for mixing, for distributing heat and chemicals, and for nurturing the earliest forms of life that might have emerged in tidal pools. Without these subtle, repeated influences, the biochemical experiments that led to life could have stalled before they ever began. In this way, a cataclysmic event billions of years ago continues to shape the environment we depend upon today. Beyond the moon, we see how the architecture of the solar system itself contributes to habitability. Jupiter, the massive gas giant, shepherds asteroids and comets, redirecting potential threats and limiting catastrophic bombardments on Earth. Saturn, Uranus, and Neptune play roles in gravitational stability, subtly affecting planetary orbits and long-term climate patterns. These interactions, often invisible, form a network of protection and regulation that supports life on our planet. Even the most minor changes, a slightly closer Jupiter, a slightly smaller Earth, could have yielded a vastly different outcome. In this light, Earth is not simply a product of its own formation. It is the result of a broader, delicate orchestration across the entire solar system. Expanding our view further, we recognize the role of chemical enrichment. Theia, in its death, not only shaped the moon and the tilt of Earth's axis, but also contributed elements to the planet's mantle and crust. Trace metals, heavy elements, and even potential volatiles were redistributed in the aftermath, setting the stage for the complex chemistry that would later support life. The very rocks beneath our feet, the oceans that lap at the continents, and the atmosphere we breathe carry within them the fingerprints of an event that occurred billions of years before humans walked the Earth. Our biology, our geology, and our climate are intertwined with this legacy, emphasizing that habitability is not merely a matter of orbit or distance, but a culmination of violent transformative events. The rarity of habitable worlds also invites reflection on the statistical improbability of our existence. While stars are abundant, planets with stable conditions, protective atmospheres, and suitable distances are rare. Among those, even fewer experience the precise circumstances needed to develop and sustain life. The universe, in its vastness, has produced countless failures, planets that froze, burned, or lost their atmospheres. Earth stands out not because of perfection, but because of an extraordinarily fortunate series of near misses, interventions, and alignments. Each of these factors, when considered individually, might seem minor. Collectively, they form the foundation of everything we recognize as life, stability, and habitability. As we contemplate this perspective, it is impossible not to marvel at the role of time itself. Millions of years stretch into hundreds of millions, epochs layered upon epochs, each contributing incrementally to the conditions we now experience. Plate tectonics reshaped continents, volcanic eruptions released gases that thickened the atmosphere, and oceans expanded and stabilized. Life, once it emerged, adapted to these conditions, exploiting the rhythms set by Theia's collision, the moon's pull, and Earth's precise orbit. Every season, every current, every cycle of growth and decay is, in some way, a reflection of cosmic events that occurred long before humanity existed to witness them. Yet even as we celebrate these fortuitous circumstances, we must recognize the fragility inherent in such a system. Earth's balance is delicate, maintained by forces that continue to operate on scales far beyond human comprehension. Small perturbations, a large asteroid strike, a shift in solar output, or the gradual drift of continents, could have cascading effects on climate, sea levels, and ecosystems. Life, while resilient, relies on a planetary system tuned with remarkable precision, one shaped by both chance and catastrophic intervention. Looking outward, we see that the search for life beyond Earth is as much an exercise in understanding our own fragility as it is in seeking companions among the stars. Exoplanets discovered in habitable zones around distant stars provide tantalizing possibilities, yet even among these, we cannot assume stability. The slightest deviation in orbit, the absence of a stabilizing moon, or a weak magnetic field could render a promising world sterile. Earth's story, particularly the sacrifice of Theia, reminds us that habitability is not a default state. It is an outcome of complex, interacting variables that are exceptionally rare. This perspective also offers a deeper appreciation for the concept of planetary stewardship. Knowing that Earth's stability is the result of cosmic accidents and carefully balanced dynamics casts human influence in a new light. Climate, ecosystems, and geological processes are not merely local phenomena. They are part of a continuum that stretches back to the violent, formative events of the solar system. Protecting habitability, then, is not merely a matter of ethics. It is a continuation of the stewardship begun by forces we can barely comprehend, by planets that lived and died, by collisions that reshaped worlds, and by cycles that have persisted for billions of years. In the end, reflecting on Earth's place in the cosmos, we are confronted with a profound sense of both awe and humility. Theia's sacrifice, the near misses of Venus and Mars, the precise alignment of orbit and tilt, and the timing of chemical enrichment all converge to create a world capable of sustaining life. Our existence is not guaranteed, nor is it merely probable. It is extraordinary. And as we look outward to distant stars, considering the countless worlds that might never have been, we carry with us the knowledge that Earth's story is unique, precarious, and wondrous. It is from this understanding that we can begin to appreciate the larger narrative of life, habitability, and cosmic contingency. The lessons of Theia, Mars, Venus, and the solar system at large teach us that life is not simply a matter of chemistry or physics. It is the product of rare events, careful alignments, and resilience in the face of cosmic chaos. Earth's oceans, atmosphere, and biosphere are gifts, emergent properties of processes that spanned billions of years, and their presence is a testament to the extraordinary combination of circumstances that made life possible. As we prepare to move forward in our exploration, looking beyond the confines of our solar system, we carry with us this sense of rarity and wonder. Habitable zones may exist elsewhere, yet the fragile balance observed on Earth, born of collisions, moons, magnetic fields, and orbital precision, remains an elusive benchmark. Each new discovery of a distant planet capable of supporting life invites comparison, reflection, and humility, for it is in Earth's story that we see the improbable convergence of events that made existence possible. And so, we leave behind the immediate lessons of Venus and Mars, the solar system's near misses, and the fragile architecture that sustains life. We carry forward an awareness that while billions of stars shine across the galaxy, few harbor planets where life might flourish, and even fewer do so with the intricate balance we observe on our own world. Earth's habitability, shaped in no small part by the loss of a single companion planet, is a reminder of the extraordinary, delicate, and improbable chain of events that have allowed life to emerge and persist in the cosmic vastness. And from this understanding, we begin to trace the story of life that blossomed on a world sculpted by cosmic sacrifice. Earth, now stabilized, gradually cooled. Oceans began to form as the molten surface released heat and gases, and water condensed from the thick, volatile atmosphere into vast, shimmering seas. These waters, gently lapping against the emerging crust, were the first signs that life could begin to stir. A world capable of nurturing the complex dance of chemistry that would one day give rise to living organisms. The tides, driven by the newly born moon, moved rhythmically, shaping coastlines and stirring nutrient-rich waters. These tides, a direct consequence of Theia's impact, provided not only a mechanism for the circulation of chemicals, but also a persistent reminder of the planet's unique history. Beneath the surface, in the cooling oceans, the earliest microbial life began to emerge. Cyanobacteria painted the waters with microscopic traces of green, shaping the atmosphere with the slow release of oxygen. In the quiet persistence of these tiny organisms, we witness a world in transformation, where the earliest forms of life took root. It is remarkable to reflect that such simple beginnings, so delicate, so vulnerable, were possible because of a lost planet whose destruction had gifted Earth with a stabilizing axis, a protective magnetic field, and the rhythmic pull of tides that nurtured the oceans. Time moved forward, slowly at first, then with increasing complexity. Multicellular life appeared, subtle at first, creeping along the ocean floors, and then growing more intricate, more varied. The Cambrian explosion, a sudden burst of diversity hundreds of millions of years later, painted the seas with an array of creatures, some with shells, some with limbs, each exploring the possibilities of form and function. Life, once constrained by chemistry and environment, began to experiment with movement, predation, and survival. Coral reefs, primitive though they were, became bustling cities of marine life, thriving in waters that had been shaped by the gravitational and chemical legacies of Theia. On land, plants began their quiet conquest, transforming barren landscapes into green expanses, stabilizing soils, producing oxygen, and creating habitats for the first terrestrial animals. Insects crawled and buzzed across these new landscapes, and amphibians and early reptiles followed. Each innovation, each adaptation, was facilitated by the stability of a planet that had survived cosmic violence, that had been gifted with a balance allowing climates to stabilize, oceans to persist, and seasons to provide a rhythm to life. And then came the Age of Giants, the Mesozoic era, where dinosaurs walked, ran, and soared. They dominated every landscape, from dense forests to open plains, and their presence transformed ecosystems. Predators and prey evolved in tandem, their lives intertwined in an intricate ballet of survival. Birds, the descendants of small theropods, began to take to the skies, hinting at the diversity of life that would one day fill every corner of the earth. Oceans teemed with reptiles, and skies were alive with wings and cries. Life flourished on a scale unimaginable, and it is impossible not to recognize that all of this abundance, all of this complexity, was only possible because of the delicate balance maintained since Theia's collision, the stabilizing tilt of the Earth, the moderating influence of the Moon, the protection from the solar winds offered by a strong magnetic field. Yet, life on Earth was never free from the shadow of catastrophe. Asteroid strikes left craters, some spanning hundreds of kilometers, shaking the land and ocean alike. Volcanic eruptions reshaped continents, poured lava across plains, and filled the skies with ash and gas. Ice ages crept and receded, freezing and thawing oceans, sculpting glaciers, and forcing life to adapt or vanish. And through it all, Earth's stability, the gift of Theia, allowed life to recover, to persist, and to evolve in new forms. Mass extinctions, dramatic as they were, became catalysts for innovation, for the rise of new species, for the eventual domination of mammals once the dinosaurs were gone. The transition from the age of dinosaurs to the rise of mammals illustrates the resilience of life on a planet finely tuned for habitability. Mammals diversified, occupying ecological niches left vacant by the extinction of dominant reptiles. Birds continued to adapt, insects flourished, and the forests and plains became mosaics of interdependent life forms. Life on Earth became increasingly complex, delicate, and interconnected, each species reliant upon the broader environment, a world whose stability, rhythm, and resources were direct consequences of a single, fateful collision billions of years before. Eventually, primates evolved, small and agile, developing intelligence and social structures. Early humans emerged, curious and resourceful, adapting tools, language, and culture to survive in a complex world. Civilizations arose, flourished, and evolved. Humans began to manipulate the very environment that Theia had indirectly shaped, harnessing fire, cultivating crops, building cities, and exploring the planet from pole to pole. The story of human advancement, while often turbulent and destructive, is only possible because the stage was set by Theia's sacrifice. Oceans that support life, seasons that sustain agriculture, tides that influence the coasts, and a magnetic shield that protects from solar radiation. And so we arrive in the present day, standing on a planet unique within the solar system, a fragile oasis in the vast cosmic expanse. Modern cities, technology, space exploration, and the digital web of human knowledge are all testaments to the chain of events beginning with that lost world. Rivers still flow, oceans still pulse with tides, seasons continue their predictable rhythm, and life, diverse, vibrant, and extraordinary, thrives. It is almost poetic that the actions of a planet destroyed billions of years ago continue to shape every moment of our existence. Every breath, every wave, every heartbeat is a reminder of Theia's legacy, of the improbable and extraordinary chain of cosmic events that made human life possible. In reflecting upon this, we can see Earth as both a stage and a participant in a story larger than any individual life. Theia's presence is felt in the tilt of our planet, in the pull of the tides, in the protection offered by the magnetic field, and in the chemical and mineral composition of the crust and oceans. Life evolved not in spite of chaos, but alongside it, guided by the subtle, enduring influence of a companion that no longer exists. The planet that collided, that sacrificed itself, did not simply vanish. It lives on in every ocean current, in every shifting season, and in every living creature that walks, swims, or flies across Earth's surface. From the microbial mats at the bottom of primordial oceans to the towering forests of the Mesozoic, from the rise of mammals to the spread of humans across continents, the story is one of resilience, adaptation, and continuity. Catastrophes, ice ages, meteor strikes, and volcanic upheavals could have wiped life out entirely, yet Earth endured. And as it endured, life diversified, evolved, and eventually became aware of itself. Consciousness arose, capable of reflection, wonder, and the understanding of its own history. A history written in tides, in the tilt of the Earth, and in the very rocks beneath our feet. Today, when we look at the night sky, we may not see Theia, but we feel its presence. The moon, the tides, the seasons, the stable climates, and the flourishing of life, all bear silent witness to a lost world whose final act was to shape every aspect of Earth's future. It is a humbling reminder that survival, stability, and the conditions for life are never accidental. They are earned, forged through a combination of cosmic chance, sacrifice, and resilience. In this final reflection, we understand that humanity itself, every culture, every achievement, every exploration and curiosity, rests upon the foundation laid by a planet that no longer exists. To honor Theia is to honor life itself, the oceans we swim in, the mountains we climb, the forests we wander, the creatures we study, and the knowledge we pursue. Every discovery about our planet, every insight into its history, every step we take into understanding the cosmos is part of a continuum initiated by that ancient, fateful collision. And so, in contemplating the life that has emerged from Earth's unique balance, from the smallest microbe to the tallest redwood, from the earliest reptiles to humans, we are left with gratitude and awe. Theia's story, though silent in its physical presence, continues to resonate across billions of years, across every ecosystem, every landscape, and every moment of human consciousness. It is a story that reminds us of the fragility of life, the rarity of habitable worlds, and the extraordinary gifts that can arise from destruction. Ultimately, Earth exists as a singular testament to cosmic generosity. Life persists because of precise alignments, chaotic collisions, and the death of a world that could have been as vibrant as our own. In honoring Theia, we honor every river, every ocean tide, every shifting season, and every living creature that benefits from a balance that was neither inevitable nor easily achieved. The universe is vast, countless worlds are born and lost, yet here we stand on a planet shaped by the selfless sacrifice of a companion. And as we consider the human future, we are challenged to be conscious stewards of this unique world, to protect its waters, its lands, its skies, and its living diversity is to participate in the continuation of Theia's legacy. Every choice we make in preserving habitats, understanding ecosystems, and respecting the fragile interplay of natural systems echoes the profound influence of a lost planet whose existence allowed ours to flourish. In the end, the tale of Earth, life, and humanity is inseparable from the memory of Theia. It is a story of beginnings forged in fire and catastrophe, of life emerging from chaos, and of the ongoing responsibility that comes with understanding the rarity and fragility of our own world. Theia may no longer circle the sun, may no longer exist in form, Yet it endures in every living cell, in every ocean, in every season, and in every heartbeat of the planet it helped shape. Here, in this reflection, we find not only the tribute to a lost world, but also a meditation on the profound connection between cosmic events and the flourishing of life. Our existence is intertwined with the fate of a planet that died to give us the chance to live. Every ecosystem, every organism, every human story carries with it an echo of that ancient sacrifice. And in recognizing this, we are invited to live with a deeper awareness, to tread gently, to explore wisely, and to marvel endlessly at the improbable chain of events that allow us to exist on this singular, precious world. As we conclude our journey across the cosmos, tracing the story of Earth, Theia, and the countless worlds that shaped our existence, you've shared in a story that spans billions of years. If this voyage through time and space has sparked wonder or made you pause to reflect on our fragile, extraordinary planet, consider supporting our exploration. A simple click to like this video lets us know you appreciate these stories, and subscribing ensures that you won't miss our next journey through the mysteries of the universe. Every view, every subscriber, helps us continue to bring the cosmos closer to you, quietly, thoughtfully, and with the care it deserves. So, if you've enjoyed drifting through the story of Earth, Theia, and the quiet wonders of the cosmos, take a moment to like this video and subscribe. By joining us, you'll continue to explore the universe in a calm, thoughtful way, discovering lost worlds, ancient events, and the mysteries that shape our existence, all at a pace made for reflection and curiosity. Let's keep traveling among the stars, together, one story at a time.